So what I want to do is I want to review real quickly, ladies and gentlemen, of how we evaluate our trigonometric functions when we had t equals an angle. And let's just call this pi over 6. Okay? Now, when we had an angle, pi over 6, what we did for this portion is we used our unit circle. All right? Because pi over 6 gave us, allowed us to intersect the unit circle at a given point. So what we asked to do, though, is find the sine of t, cosine of t, and the tangent of t. And what was so nice about knowing the unit circle, or at least having these certain angles, when we have certain angles on the unit circle, we have the value of the point. Right? And remember, each one of these points had an x and y coordinate. Now, it was nice to understand that the sine of t, remember, represented the y coordinate. The cosine of t represented the x coordinate. And the tangent of t represented the y over the x, right? Because remember, this coordinate on the x on the unit circle had an x and a y coordinate, right? Now, there are infinite many points on the unit circle, but we only talked about so many of them, right? Really only talked about 5 in that first quadrant, right? So does anybody remember why, when we're evaluating for sine and cosine and tangent, why did the sine represent y and the cosine represent x? There's a value that's very important that made that happen. Does anybody know why? Why does the sine equal to y? Yes, Kevin? Yes, you're measuring from the x-axis, but why is it the y? Because what does sine represent? What is the definition of sine? It's the ratio of what? Yes, Fisher? Yeah? Yeah? Right? That's the opposite side. And what else is part of sine? Sine is the opposite and what? The hypotenuse. But if you're talking about a point on the unit circle, you're right. That's the y and that's the x. But what do you know about the hypotenuse for the unit circle? Right. But what is this r? What is the measure of the r? This is a radius. JJ. Exactly. Does anybody know what's the radius on the unit circle? 1. Guys, the sine, the definition of sine in a triangle is opposite over hypotenuse. However, on the unit circle, your hypotenuse is 1. So instead of it being y over 1, we can just say it's y. So that's what was so important about when you have a point on the unit circle. If you guys remember, I told you to write this down. When you have a point on the unit circle, your sine is the y coordinate. Your cosine is the x coordinate. And your tangent is y over x. Yes? When you have a point on the unit circle, yes. Okay, because remember, the unit circle is a radius of 1. That's how we came up with the unit circle. It has a radius of 1. Tangent is always the ratio of your opposite over your hypotenuse, which we're talking about the unit circle would be your y over your x. Yes? When you have a point on the unit circle, okay, your sine is represented of your angle. It's represented by the y coordinate of that point. Your cosine of your angle is represented by the x coordinate, and your tangent of that angle is represented by y over x. Okay? Yes? Question? No? Good? So that's what we pretty much discussed in 4.2, was how to evaluate sine, cosine, and tangent. And then obviously we did the reciprocal functions. But the main important thing you guys need to know is to evaluate for an angle, you just need to find the coordinate on the unit circle. So if you guys look at where's pi over 6, pi over 6, well, yeah, it was xy. But remember, if you guys know the pi over 6, that angle was square root of 3 over 2, comma, 1/2. Right? Knowing the unit circle, the point on the unit circle that pi over 6, this angle intersects, is square root of 3 over 2, comma, 1/2. So therefore, the sine is 1/2. The cosine is square root of 3 over 2. And the tangent would be, do it in your head, is going to be square root of 3 over 3. Okay? But that's not the whole major point. That's a review. That's